So let us talk about binary heap again. Here I have already discussed about introduction to binary heap. That is my previous video. You can check out the tree playlist. You can find that. So now we are going to talk about insertion in heap, or I can say creating the heap. Like first of all, let me talk about insertion in heap. Like I am going to insert an element. I will discuss how I am going to insert an element. So after that, I am going to create heap. How? See, I'm going to insert the elements, like there will be nothing at first. So I'm going to insert first element. Then I'm going to insert second element. Like this, I'm going to create a heap. So insertion and creation of heap follows the same code. So that will be, and that code is much more easier actually. Now let us talk about it. This is a max heap, right? Normally it is a max heap because the root node is greater than as the value greater than its descendant. So I need to add 40. So what you are going to do usually, you just add 40, and more than that, you know that we are going to when we are talking about heap, we are going to represent heap in array, in form of array, right? Obviously, but first of all, let me show you how heap works. Like now, I'm going to insert 40. Usually, you will insert like level wise without seeing looking at the value of the data, because it is not a binary search, right? In order to look the data and to arrange where it should come. No, it is not a binary search tree. So I will insert 40. Then what I will do, I will compare this 40 with its parent. So actually, the root node, if you consider this as a node, then its descendant should have value less than that of its node. That is what the max heap tells. But here in this case, 40 is actually greater than 5, means 5 is smaller. So swap it. So swap it, and let me make this as 40. So again, this as 40, then this as what? This as 5 I will make. Then again, my control is at 40, right? Still it is at 40. So now I'm going to compare this. Let me erase this thing. Now I'm going to compare this and this. Again, it is failing the max heap condition, right? So again swap. That means 20 is less than 40, right? So swap it. So what you are going to get is, here you will get 40, here you will get 20. So this is 40, this is 20, right? And this is again 40. So this is what happens. Now what you are going to do, you are going to compare this with this, right? Then again it should swap, because 30 is less than 40. So swap it. So my solution is what? My solution should come 30 should come here, 40 should come here. So now what the tree I got, this tree is my solution. That's it. I added 40. That's it. That is how you are going to do. So compare with its parent. That's it. That is what insertion means. For this, I'm going to write code first. So before that, let me explain you actually in memory what we are going to do. First of all, imagine there was no 40 here, like no 40. So at that time, like there was 30 here, right? So there was 30 here. So let me go back. So 30, 20, and here I had 5. Then I had nothing here, right? How to represent this in form of array? Normally, as we already discussed in previous class, simply add the values in, like in array you are going to add the values, right? That's it. In level order I am going to add now 30, now 20, then 15. Level order means you go you cover this level, then this level, then this level, like that you are going to cover. Now 15, then 5, then 10, then 12, then 6. So whatever the new element that you need to add, right? Here 12, it is 6. Again, whatever the new element that you need to add, so you need to add here, right? Means simply like a level order. That means where you are adding here only. So 40 I need to insert. So index always starts from 2. You know, in heap your index should start from 1, because from 1 I said 2. So it will start from 1. Why? Because it is an array based tree. You are representing tree in form of array. You know how it works, right? So if I am in node, let me write this as 8. So if I am in node 1 I, then its right child will be where, sorry, its left child will be there, where it will be at 2i, where will be its right child, it will be 2i plus 1. So for example, for 20, 20 is what, it is at index I is equal to 2, 2i is what, 2i is it is 4. So look at the 4, fourth index, there is 5. So 20's left child is what, 5. So again, uh, if you do 2i plus 1, you are going to get 5. That means you are pointing at 10. So 10 is what, right child of 20. So that is how it works. Similarly, if you are in index I, then what is its parent, right? What is its parent, I am asking. I am not asking for what is its child. So simply what you are going to do is, if you are standing at index n, imagine, so what its parent, its parent will be at n by 2, right? N by 2 it will, there will be at, it will be at n by 2. Forget about left and right child, because imagine you were at 10, right? You need to find its parent. So take the index 5, 5 by 2 is what, 2.5, or in integer it is 2. So go to 2, you have 20. So 20 is the parent of 10. So 20 is the parent of 10. So it's satisfied. So that is my one of the most important formula for this, not to solve this problem. So what you are going to do here, so let me erase this. So again 40, you have, right, you have 40. Now 40 is at index I, 8. So do 8 by 2, what you are going, 4, you are getting 4. So compare this and this, you compare this and this. So again, what we have did here, we compared, if parent is less, then swap. So again I will swap, right? I can swap, I will swap, but in code I will optimize this. Without swapping only I will do. Let me show this afterwards, but now let me swap, but in code I am not going to swap. So again, compare this 40 with I by 2, that is with 20. So 20 is again less than 40. So what you are going to do, you are going to write here 20, no sorry 40, swap, that is you are going to do swap 20, then again compare with this, then what you are going to get, here 40, here 30, right? Obviously you should get this one, then 40 here, then 30. So if you draw simple level order tree, what you are going to get, you will get the tree that we already found, like in tree we have did, right? Same tree we are going to get. So this is what insertion of the element means. So now I need to write a code, right? I need to write a code. So the code will go like this. Let me write a function here itself, then I will copy paste that function. So I have a function which returns what, it returns something. Then let me call the function as insert, insert, insert. So let me make this as let me give the background as blue. So what I will ask, I will ask for, obviously I should ask for normally for the array, right? I need array. Then you need to pass me the index where you are adding the element. Obviously that will be last index, because you need to add at the last index itself. So he will give me 8 in this case. In this case n value is 8, you need to pass 8 here. So array normal, this array what we are discussing, right? This array you need to pass. So let us come to the code now. Now after that I'm going to create a variable. Let me call it as temp, temp, right? Okay, now let me take another variable. Let me call I let it be n. Okay, now I will go from while HILE, while, see temp means what. See, let me give temp value as like this, a of n I will give, means the last element, that is the last element, recently added element. In this case 40. In my example, a of n is what, a of n is a of 8. So it was 40 previously. I am talking this one is after inserting, doing everything, that is what I got. Previously it was 40, right? So it was 40. Now it's 40. So if a of, right, a of, or another another condition that I am leaving is I should be greater than 1. So why I should be greater than, you should get a doubt now. Like I am comparing this one and this one, right? This one and this one also I am comparing, but I will not reach 1 itself, right, in this loop. Then how swapping will take place? So let me answer that your question. Like So before that, I should be greater than 1. Okay, it should be greater than 1. Now add, then a of, that is a temp, if temp is greater than, right, greater than a of I by 2, right, means for in this case 40 I added right here. So 40 is it greater than 20, like that. The first step that as discussed, you need to ask that for the user, sorry, for, you know, this is the, like, a step that you need to follow now, right. Now, is it a, if it's satisfied, what you need to do, swapping. But actually I don't swap it at all. What I will make is, I will make a of this n will be sorry, a of n, right, a of I, actually I is pointing to n, so I should be equal to what, it should be equal to a of I by 2. That means what I did, I had 40 here, right, initially I had 40, so I'm swapping, I should bring 20 here, right, I need to bring 20. So for your understanding, let me draw the array again. Like I was inserting 40, right? Let me insert it again. Like 30, 20, 15. 30, 20, 15, 5, 10, 5, 10, then 12, 16, 6. Now what I need to add? I need to add 40, right? I need to add 40. So this is 1, 2, 3, 4, 5, 6, 7, 8. So is 8 is greater than, is at the index 8, what the element is there now, that is a of I, is it greater than 20? It means here it should be, okay. Now this was the action, okay, it is correct, everything is correct. So is this 40 is greater than 5? Yes. Then what you are going to do, you make a of I, that is 40, replace it with what, I by 2, that is what, 5 you are replacing. Now you may think like I need to make 40 here, right, you need to make 40. No, I will not make, I will not make, I will just keep it as it is, like let it be 5, right, let it be 5. Let's see what happens. So that is my, what my intention is. Now I will make it, I should make this 5, obviously I should make this this 5. So here I am not going to insert 40 just to reduce the time. I'm going to explain you again. Okay, now next what you are going to do, next I have to do, I should be equal to, I should be equal to I by 2. That means I should reach, again I should again check with the next condition, right. So you go on doing that. Whenever I becomes, when I becomes 2, that means greater than 1, right, when it becomes like that, then what you are going to do, you come out of the loop. After coming out of the loop, I will be where, I will be at, I actually, why this loop ends, imagine there are two conditions again why I loop should end. Imagine in this case, I our loop, when I am adding 40, our loop will end because I has reached 1. So I will be reaching 1 as I explained you earlier. So I reached 1, that is why I need to stop. So if you stop, it will come out, right, the control will come out. So after coming out, where is I, is at 1. So a of I should be made as temp, right, I need to make this as 40. You go on doing, and you, like, that is what, that is how the code will work. So instead of swapping and swapping and swapping, once, only once I will replace this 40. Whenever I get, when I feel like temp is greater than a of I by 2, then only I will simply copy that, at that index I am going to put 40. So I don't want to swap it again I need to take the 40, then again compare with its I by 2. I don't do that. So if you try go on looking at this, how it is working, then you easily find out. It is so much simple talk, simple thing. Now let us see the creation, how you are going to create. So it is again simple, it is so much simple. So here I have discussed, I think I have written the, okay, let me, okay, so let me do it here. So I need to insert it, I need to insert. Now imagine I have some elements, I have some elements. So those elements are here, that is there, I think here I have written. So I need to insert this element, That is what my objective is. Now I will take this and I will paste this somewhere here. So now what I do, you insert 10, don't look at the first element you don't need any comparison, you simply insert 10. That is, I'm talking 1 2 indexing, right? I'm talking about 1 2 indexing, 5 6 7 8. So again, now 10 you insert. Now what, I is at 2 means you need to insert 20. So after inserting, you check the 20 is at what index, right? It is at index 1, this is index 2. So do 2 by 2, so it is 1. So compare with that element. So again 10 is less than 20, so swap it. So write 20 first and 10 later. So this is what I got. So index is 1 2. Now we need to insert what, 30. Here you will insert 30. Again 30 is at what index, 3. So 3 by 2 is 1, what, 1 by 1.5. 1.5 means what, 1. So compare with this one. So 20 is actually less than 30, so make it like this. So swap them like this. I'm going to insert, right? And then again, now you need to add 2 25, sorry 25. So if you add 25, 25 is at which index? This is 1 2 3 4, fourth index. Do 4 by 2, that is 2. Compare this and this, again 25 should come here. So you go on, make this thing. So it is, you can take it like a homework, but that code will remain same. And here while inserting your code, again you need to modify. This is a normal code. In main function, what you are going to do, in main function it is simple. Again it is int main, now I will take an array. So before taking an array, like I have taken this array, right? This array I have taken. So what is the final result of this array? What is the array output should look like? So it is simple. Again I will write this output now. After that you can first of all do that thing what I said. You go on doing this, right? When you do this thing example, again you should go back, unless that like just like do how I have inserted, same thing you need to do, right? Now this is array. Imagine this is only the thing that I am giving as an input. So what I am giving is 10 and 20, then 30, then 45, sorry 25, now 5, now 40, then 35, right? 35. So this is how it looks like. Now what I am going to make is, I am going to copy this array and I am going to run in my code blocks, and I should get the same result. Like what is the result? If you solve this one, the result should be what? Let me highlight this one again. Just for copying I wrote this thing. So this is my input array. Insert by in this order I have inserted. So how it should be, the output should look like. Let me again write the output here. So that is what the output we should get, 40. Again let me make this as like this, then 40 25, then 35. So you should get this if you do that work, then 20, then 30. That is what you get. So this is what the output I am expecting, right? This is 10 20 30 25 5 40 is my input. So I will copy this. So here I am going to write the code for int main. So I have an array. Imagine I have an array. Let me call it as ARR, and it has some size. And let me pass all the values. But always remember, it should start from where? It should start from one index. So I will make first one as 0. So it is common sense. Now int. So I am going to make an for loop. Like I need a for loop, right? I need to go on inserting all the elements. So I should be equal to what? 2. Then why it should start from 2? The first one is already sorted. It is already sorted. You don't need to compare. It is not sorted by, but it satisfies all the condition. So you don't need to make it again. You know that, right? So I'll explain same code I'm writing here also. Then till 7 you need to reach, because here it is 0, here it is 1. Sorry, this is 1 2 3 4 5 6 7. Seventh index I need to reach. Then I plus plus. Then I will go inside the loop. Then I need to insert, right? I will call insert, insert. And there what I'm going to pass, I am going to pass array. Obviously I should pass the last, I should pass I, because I need to insert, right? So like I'll be keep on inserting each and every element in this array, and I will store the result, right? The final result that I am getting here, that is this line, should be stored in the array by the program. So I will print that program. So sorry, I will print that array. I should get what I am expecting. So for int I is equal to 0, actually 0, I will start from 1. Then I less than equal to 7, I plus plus. Then I will get inside. Then I will print couts out, arf I. Then give some gap here. So let me take out this and let me copy this first. Let me run in my code blocks. So the code blocks here. So actually I have did this already. So again let us do it once again. Let me make it as some, let me give some comments here. Now I will copy and paste. So I will write normal, the first 2 lines using namespace std and using iostream library. So I will give this. So if I run, I should get the result as what? I should get the result as what I said earlier. Now it is giving some error. Expected, okay, some basic mistakes are there here. So here a was not declared, a was not arr, right? Array was arr. So I'm running. So what I'm getting, 40 25. Let us compare. So let us compare with what? With this 40 25 30 10 5 20 30. So you got the output. This is how insertion work. In next video I'm going to talk about deletion. Deletion is so much important. Why? Because if you know that in my other playlist, that is sorting technique playlist, I discussed about heap. I have not discussed about heap, actually. Heap sort, right? Because I am covering here, that heap sort, but I am going to add this video there also in that playlist. So heap sort is nothing but deletion of the element in heap. So there will be, like, you will have doubt how it is possible. You are deleting, how can it be sorted? I'm going to discuss in next video. So thank you.